Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see what's there in today's daily challenge on Leetcode. And today I will show you two approaches. First, I will show you the ON approach and then the O of NlogN approach. So why I will because this approach is much easier to understand. This is much more difficult to understand, but I will show you this one also because you should know that if in case something does not click in your mind, what you should do, what can be an editor to do it brute force manner. Okay, so I will tell you both of the approaches, so stay till the end of the video, and if you like the video then definitely subscribe to my channel. It gives me motivation to put more effort in making such videos. So let's just start. So, using a robot to print the lexicographically smallest string, you are given a string S and a robot that currently holds an empty string T. Apply one of the following operations until S and T are both empty. Okay, so we can remove the first character of string S and give it to the robot. So you can just ignore the robot, remove the first character of string S and append it to string T, then remove the last character of T and write it on a piece of paper. Okay, and you need to tell that the smallest lexicographically smallest string that can be written on the paper. So let's take this example BAC. Let's try to understand this example first, and then we will go on to see the intuition of how exactly you should do this. So let's say we have something like BAC. So what it does, this is the string S. What you can do, you can take the first element. Initially, you have a string T which is empty. You can take the first element and append it to T. So now you have B. Okay. Then what you can do, you can take this A. Another now this is having AC, right? Now this is having AC. Now what you can do, you have only B as the string. You can take A and append it to this string. This is the string S, this is the string T, and this is what you write on paper. Now you write nothing on paper. Okay. Now you append it to string. Now you have the string T as BA. Now you can take A and append, write it on a piece of paper. Now the string T becomes, the string S is still like C. String T after transferring A to B has become B. Now what you can do, you can transfer again B to A, so you get AB. You get AB, okay. And then what you can do, you can just transfer C from S to T and then again T to B. So you get ABC, which is the in the lexicographically order. Okay. So this is how you are doing. So this might be a little complicated to understand this one, but I am telling you how you should think. So first of all, you see you have a string S, right? You can take the first element of string S and append it to the last element of string T. And the last element, you can append it to the first element written in paper. So you can always do this. So what you are doing at the end is like this element, this T is behaving like a stack. You see, this T is behaving like a stack. You can append more and more element at the back. Okay, you can just append more and more element, you can just put more and more element, but when you are taking from T, you are only extracting the topmost element. Okay, so this T is nothing but a stack. So also you can process the elements from left to right in original string S. So what idea will this give you? To get the lexicographically smallest character, what you can do, first thing which will come to your mind is take all the A, then take all the B, then take all the C. So something like this should come in mind. But they may not be in the proper order, right? So you need to see how to exactly get them. Okay. So let's say we have some A written here. We have a very long string. We have some A written over here. Then something is there. Then maybe B. Then again something is there. Maybe we have A again. Then we may be having B followed by A again. Then we may be having something like C. Again, let's say another C. Again, let's say F. And so on. We are just having. Okay. Let's say this is our string. So what can we do at first? So ideally, for the lexicographically smallest order, we need the three A's at the first, right? So we need the three A's at the first. Then I will want maybe if I can get some B. Then I can get some C or not. Okay, so this way I will just think. So what you will do, you can extract always the first element and store it in the stack. In the first element, store it in the stack. So what you can do, you can always take the first three A's in this order. Okay, you take the first three A's and store it in the paper. Okay, but now in the stack you have this string without A, this whole prefix without A you are having, and you can only take them in reverse order, right? So if you see, the next character which is coming to me is C, but I have the immediate left character B, which I can take it. So I will take it in this way. Okay. So dot 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 means it. Some characters are there also, but they are much larger than A, B, C, D, E, F. So they are, let's say, X, Y, something like that. Okay, which we cannot take as of now. Okay. So we take B. Now, since here is some larger character, I cannot take this B, because if in order to take this B, I need to take this larger character also, right? But I also have C in my front. So I will take C first. So I have C, then again I go for this C, then again I go for this F, and I so on. I just do it. And once we are done, what exactly is meant by done? If I am I've taken all the characters in order till Z. Okay, now not necessarily till Z. Okay, so I will take the character from the left also if I have something less than which is about to come. Okay, so these all characters at the end I will just append it. At the end I will just append it. Okay, so you first thinking, this should be the first thinking which should come into your mind. Then you should think something like, how will I know which is the future character which is about to come, right? So what exactly happened, if you see, as I was explaining you, what exactly happened, I was able to take this B. At first I wrote 3A and I was able to take this B. Why? Because I knew that my next character is about to come, which is C, which is not B, right? Or let's say this is D, this is D. Okay. No, so and let's say this is something like C. This is something like C. Okay. So even in this case, I will take C, A, S, C, and then I will take D. Okay. But what if there is a B present in somewhere? Then I will not take C. I will go for the B, because that is the lexicographically smallest. So we need to understand that which is the next character which is smallest and it is about to come. Okay. So what we need? We need the minimum character which is about to come. Okay, I will try. I have to get this, right, the minimum character which is about to come. Then what I can do, if I can track somehow, the remaining things become very simple. Like I have T is acting exactly like a stack, so I will store things in a stack. Okay, and I will pop the stacks one by one. Unless my whichever character is smaller, I will just take that. Okay, the minimum character which is about to come, I just need to take. So if I see the minimum character which is about to come is D here, that character is greater than my stack.top. This will be in my stack.top. After I extract 3A's, my stack will contains of nothing but this dot 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 B and this dot 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 C, right? My stack will be, the condition of my stack will be this. So stack.top, while I can also do like, while my stack.top, my top element is less than D, which is about to come, which is the minimum element which is about to come, then I will just push my elements in the top, in the stack. So how will we achieve? Now the question arises that how will we take care of the minimum character which is about to come? So what we can do this, there is a neat trick for that. I can take a map. I can take map or an unordered map, and then I will store the frequency of all the elements. Okay, I will store the frequency of all the elements. So A will contains 3, B will contains here 1. Okay, C is here 1, D is here 2. So whenever I am iterating through these elements, I will decrease these frequencies. So I will get to know that which is my next element, which is which is going to come is smallest. Like the minimum character, I will first initialize it by A. Okay, I will keep incrementing this minimum character. It will go to B, then it will go to C, and it will check that whether every element is the current pointer. Whenever is my current pointer, in that place, this element, I mean, the frequency is 0 or not. If it is not 0, it means I have something, right? I have something. So at A, my frequency of C becomes 0 because I have already iterated through that. So I will get to know that the next character minimum is D. That I can get from the map, right? So let's see how to implement this approach using the map. Okay. Uh, so first, let's try to take the size of the string. If you don't understand any portion of the video, just you can ask me doubts in the comment section. I will just tell you. You can post the timestamp, right? I need character. I need the store the frequency of all the characters. Okay. I need to store it in the map. Then what I can do, I can just go through the string. I can do map of si plus plus. Simple. This is quite simple. I am just storing stuff in my map, storing the frequencies in my map. Okay. So let's have some answer variable. Let's have some string answer which I can append. I can append the value. Okay. Now what I will do, I can go through all the elements, right? Yeah, I can go through all the elements, and at first I will just take the stack. I will just put it in the stack. Whatever I'm getting, I'm just putting it in the stack. Now whether I want to take it out from the stack or not, that I will decide later. So I need to have a stack also. Stack of characters st. So I am just pushing the thing in the stack, and as I process this element, let's currently decrement this map. Okay. So let me keep this name as count. It will be easier for you to visualize. I will also show you the dry run of this. So you have the count. Okay. So now what you can do, you have decremented the count. Okay. Now, while you have a minimum character, right? As I told you, I will track a minimum character which is about to come. So char mn, at first, let it have a, and this is the minimum character which is about to come next. Okay, next which is about to come. Okay, so while this minimum character should be let's say and then the count of this minimum character, while the count of this minimum character equals to 0, it means that let's say a might not be there, right? A might not be there. Let's say after C, something like G directly comes in the string and the other characters are not present. So in those cases, the count of the minimum characters will be 0. If I have a count of 0, I will increment my minimum character. It means that it will change from, like, if it says A, it will change from A to B, B to C. It will just, this increment just means that it will just go on changing, right? But you need to take care that this is not Z, because I cannot increment Z, right? Nothing is after that. So I will just say that mn not equals to Z also. I need to take care of this. Okay. Okay. So now I have the minimum character which is about to come next. So as I told you, while the top element of the stack is less than the minimum character which is about to come, I'm doing this while the st dot top is less than equal to the minimum character which is about to come. What I will do, I will just answer dot push back. I will just push the minimum character, and I have used it from the stack, so I will just pop it. Okay, and I also need to take care that I just can't just simply check the stack, right? Initially stack will be empty also. So while stack is not empty, that should also be a case. While stack is not empty, then I can check the stack dot top. If stack dot top is less than the minimum character, uh, then what you should do, you should push this minimum character. Okay, you should push this, and you can do stack.pop. Okay, what you can return is return answer. I will also show you a dry run of this. Let's first check if it works or we have done any mistake. So apparently we did mistake. Let's try to see what is the mistake in our approach. So okay, so you see here why I am pushing the minimum character. I should push the top, right? Top of the stack. Yeah, I need to push that first. So let's try to run it now. Yeah, we got the accepted. Let's try to submit it. Okay, runtime is like 13.86. So you are using a map. So let's try to make it unordered map, as unordered map many times uses the amortized amortized cost. So that is less. This is most often O of 1. If you don't know this, let's try to see if the time complexity increases little bit also. So it increases a little bit, not much, but you are close to O of n. You are close to O of n. How can you even do better than this? Somehow, some these things maybe some problems. Okay, whatever. Let's try to do a dry run of this using one of the examples. Okay, so I think you have also understood it quite well by now. But let's not give it up. Let's try to do the dry run first. Okay, so we have this code with us. Let's try to see what happens when we have the case, let's say VZHOFNPO. Okay, I have written this test case in my copy, so I will just try to do a dry run of this. So what you see, at first you have a minimum character initialized as A, okay, but you don't have anything as A, right? So what you can do at first, you have the stack with you. You can push this S of I in the stack and decrement the count. So from the map, you can get the count of all characters, right? Count of all characters. I'm just not showing that. Just know that I have the count of all characters from the map, and minimum is A. Okay, so what I can do, I can just push this V in my stack. At first I'm just pushing this V in my stack, and then I'm just doing the decrementing the count of this V. So this minimum will go now while it is not Z and count is 0. So A count is 0, B count is 0. You can see it, right? So what is the minimum that it will take? It will first take F. A, B, C, D, E, nothing is there. So it is F. So minimum will now be set to F. So these two things will happen. Okay, minimum will be now set to f. So when it has been set to f, while stack is not empty, you will see the stack is not empty and stack dot top is less than equal to minimum, answer dot pushback stack dot top. So what does this mean? Uh, this stack dot top v, is this v less than equal to this minimum f? So it is not, right? So it will not enter this while loop at all. It will not enter this while loop at all. And what will happen is that uh, in the first iteration we have got stack v in the stack. So till all these iterations, the stack will just go on incrementing from v. Then it will get vz, vzh, and then it will go till vzhof. Okay, now when it has got f, it has also decremented the count of f. Okay, now the minimum character after f, it has gone, is it will check what is the next minimum character which is about to come. Okay, next minimum character which is about to come is nothing but MNOP. So N, okay, it will go to N. This is the next minimum character which is about to come. So VZHOF, you get this in the stack. The stack now contains this. Okay. So you see the next character which is about to come is N. So is N, you will check here that is N which is greater than stack dot top. Now the stack dot top has f in it, right? So yes, definitely this is greater than stack dot top. So this f will be written on paper and this f will also be popped out. Okay, so as you have popped out this f, now you check whether n and o is still which is greater. So n, m, and o, so o comes after n, so you will just go to the next, you will just add this n here. In the next iteration you will just go and add n, and then again you will check, then minimum character, it will go from n o, from n it will go to o, and then you will see for these two cases, you will see that for these two cases the minimum character o is greater than equal to n, again this o is greater than equal to o, then again this o is again greater than equal to h. So n, o, h, all of these will come into this paper. Okay, as you have written now the NOH on the paper, and the minimum character which is O now, it will get converted to P. Okay, so after this has reached O, it will write again this O again. Okay, now the minimum character is P. Okay, now you have everything on the stack, right? You have this P on the stack also. So what you will do, you will just keep iterating from the stack. Now the minimum character which is next after P is nothing but Z, right? You have iterated through all the variables. So you have the minimum character as Z. So everything is smaller than or equal to Z. So you will just keep on writing P, Z, P. So this will be the final solution to this. I hope you understand this. Yeah, I just showed you the dry run for your better understanding, but I think it was not that much required. I have already explained you the complete approach earlier in the video. About that O of n log n solution, this was clearly O of n, right? You are using a map, this map is practically uses O of 1, so it is also sometimes O of n, but mostly O of 1. It is also known as amortized O of 1, and this is definitely O of n. You can check. So we have O of n, but when I was first solving this problem, this n log n solution did not come into my mind. Okay, so what did I do exactly? I understood that I need to check that which is the next character which is about to come, which is the next smallest character which is about to come. But that using of map and using this minimum variable, it did not come into my mind. So how did I do this? So if you see my submission of Leetcode, exact first submission which was accepted, if you try to see this solution, I used a multiset. Okay, so what I am doing, I am taking all the characters of the string and sorting. This multiset sorts, right? So it will sort and store all the characters. So from this set, I will try to take the smallest character which is about to come, and remaining things is pretty much simple. What I do is that if the smallest character is which is about to come, is greater than stack.top. So I was not using a conventional stack. This is nothing but stack.top. I was doing pushback and popback in a vector. I was using that as a stack. So then we use the answer dot pushback and popback. These are the same things which we are doing. The thing which I am changing here is that to keep track of the minimum element, every time I am finding this element Si in the multiset and I am deleting it from the multiset. This both takes log n time, and hence this is an n-log-n time complexity. So how this exactly work if you try to understand this? Let's say I have all the elements in a sorted fashion, A, B, C, D. And as I'm going through some elements in the string, so let's say in the string, I have something in the order of A, and then C. So I will just find it from the multiset, delete this, then delete this. So whichever is the first element of my multiset, that will be the next minimum character which is about to come, right? So the first element of the multiset is nothing but set.begin of star. So that is how I was taking care of this. And at the end, I make sure that I just put the remaining all element in the stack. That's how. But since this uses nlogn, you see it is only beat 5%. So yeah, this is most of the time not so much correct, but yeah, sometimes it does give you an idea that you can perform maybe better. So yeah, that was all for this solution. It was definitely a medium kind of problem, you can say. But I hope your day is going to be really easy. Thank you so much.